equals to E, I can just eliminate. And I redo the process, but basically I have done it. I will not. Here, for example, BA, But blindly, I will redo the process. I cannot think as if you want. So let's say B goes to E, okay. Here, AC, oh, I got it. AB, I'm sorry, AC, I got it. Here, BCA, I got it. B goes to E. BCA, I got it. Both go to E. CA, oh, wait a minute. Do I have CA? Yeah, I have it. Yeah. Okay, next one, B. CA, I have it. A, I have it. BA, I have it. A, I have it. So blindly I do it again, right? But I did not get any empty new rules. I did not get any empty rule. I'm done. And if you go at home, you can check this grammar is the same as the other one. Okay? So by eliminating, okay, we eliminated the empty rules. Now, the rules that are left will be either on the right side, you'll have only non-terminals. Okay. And if you have exactly two, that's good. That's in Chomsky form. If you had one or more than one, we have to convert this to equivalent rules with only two. So this is a problem, or this is a problem. Okay. Or on the right side, you have a combination of terminals, or a combination of terminals and non-terminals. Okay. These rules are a problem. They're called chain rules. Okay. The chain could be of a length more than one. So you can have A1 goes to A2, A2 goes to A3, and so on, goes to AN. 1 goes to 1. The chain will be finite because the number of terminals is finite. Okay. So eventually, for some symbol, it cannot go to 1 non-terminal. Okay. If it did, it will have to be one of those if there is the maximum number of non-terminals. So you will have a cycle, which can happen. We'll see what to do in that case. But if you have a cycle, 1 goes to 1, A goes to B, B goes to C, C goes to A. Right. Or it will terminate because you went to something else, like a sigma star, or a combination of sigma star and non-terminals. I'm saying this. Let's say we have a chain. Let's take an example of a chain of length 3. Okay. Let me start up there. Okay. So A1 goes to A2, A2 goes to A3, and A3 goes to A4. The chain eventually will stop. You have a finite number of symbols. So let's say A4 goes to, I don't know, AB. Or A. Right? Okay. Now, let's also, A2 goes to A3, that's part of the chain. A2 is involved in a chain. But also, there might be another A2 rule, right, that is not part of the chain. A2 can go to other things also. So let's say he goes to A, B, A2. Right? Okay, so you have this. What is the chain? 1, 2, 2, 3, 3, 4, 4, stop. How do you get rid of the chain? First, you have to recognize the chain. You must have an algorithm to identify the chain. Look at the grammar, find the chain. I have 1, 2, 3, 4, that's a chain. Okay? So you recognize that somehow. Okay? Now, I have to convert the grammar and delete the chain but not change the grammar. Right. I said, well, A4 goes here or here, whatever this is. So you go to the previous step in the chain, A3, A4, right? And you delete this rule, and you substitute him by what? Well, don't go to A4. Go to wherever A4 goes. So I'll go to A, B, or A. So that's what I said here. Right? Substitute instead of A4 what it is. Okay, so let me do it. Can I erase it here? Okay, so you can repeat, write it again. So I'm going to delete this and put A, B, or A. Now, I'll go to the previous, I go to this one. A2 goes to A3. A2 goes to A3. Well, don't put, keep, it also goes to other stuff. This other stuff, keep it. I don't want to change that, to touch it. But when he goes to A3, instead put where A3 goes. Yeah, A, B, or A. So, okay, A1 goes to A2. Okay, I don't need to say go to A2, just put where A2 goes, which is all of these that came from the chain, but also that, because A2 also goes to, he's involved in a non-chain. You have to carry that with, right? That's what I said there in the diagram. So instead of A2, substitute what came from the chain plus that. So he goes to AB or A or AB, A2. By doing that, you get rid of the chain. Now you might have many chains in a grammar. You grab it one chain at a time, you right, get rid of it. Just one non-terminal. We're closer to Chomsky to binary form. The rules will look like, okay, on this side, how many non-terminals I'll have? Or rules. There's a process for that. Then you get rid of the chain rules. That's step 3. Okay, now step 4. Let me erase this so I can write. Okay, step 4 is this. What if you have a rule and on the right side he contains at least one terminal? I know that. You still keep popping the windows around, right? To confuse it. Okay. So step 4. If you have a rule, at least one terminal here. So like that. Here's what you do. You introduce new symbols. One for each terminal symbol. And depending on, I don't know what symbols I have in my grammar, right? So some new symbols, let's call them some Chinese characters. Like, the character, right? This goes to A. Right? These are non-terminals. Okay? And this goes to B. So for each terminal, right? For each terminal you have in there, you introduce new non-terminals and you make them go to just one choice, to the terminal. Okay? So let's do that. And let's make it, so I can copy. All right? And then rewrite the rule. As A goes to, instead of all lowering, what do you put? Non-terminal. So the objective is make the rule so that his right side has only non-terminals. That's the objective. So instead of A, I say whatever, this one. Followed by B, followed by B, followed by this input. Followed by A. Right? So in this step, every rule you have, you will convert it to a rule that on the right side has non-terminals only. The only rules who have a terminal on the right side, it will be one terminal. Like X goes to A or whatever. It will be one terminal, right? Either of the form non-terminal goes to an individual terminal, which is allowed in Chomsky form. Remember? Chomsky form said a convex free rule goes to exactly one terminal, which is not empty. Okay, yeah. Right? Or the other rules will look like, the only thing you have left here would be non-terminals, a chain of non-terminals. And it will only be one. It will be either two or more. Right? Okay, now these rules still bother me. They're not binary. So step 5. What do you think you do with rules like that to make them binary? You take 2 at a time, or here. I can take, this process is not unique, but it doesn't matter. You will get a binary grammar. You can take this chunk of them and call it a new non-terminal, W. And instead of this rule, you say X goes to what? WXN. And then you add the rule, okay? W goes to X1, X2, Xn minus 1. You made him binary, and you reduce from size n right side to size n minus 1. So it's another iteration process. And while keep substituting until you get binary. All of them will be binary. Okay. Then, well, this might not, if it's binary, you're done. If it's not binary, you will take what? That part of it, you will call it, I don't know, WZ or something? Or W1 or whatever. Okay, let's call this W1. We'll call this W2. And then this guy looks like W1 goes to W2, Xn minus 1. And then W2 will go to whatever. But eventually, this is binary. This binary, you stop. Eventually, for sure, this will be binary. You stop when the size is 2 over here. Okay. Stop if the size is 2. And you made all binary. Okay. Take this grammar. I could also throw, I don't have any useless or unreasonable. Like I could throw them in, but you know how to reduce those, right? Okay. So everything is useful and reasonable here, that's fine. Reduce it to Chomsky form. So tell me what to do. Step 1, what should I try to do? The empty rules. Remove the empty rules. Okay. Before I do that, what do I have to find? All the symbols, the non-terminals, that? Yeah, let's say I'll do the unreachable and the useless. Okay. And here, everything is reachable and everything is useful. Okay. I did that. Step 1. Now, step 2. I'm finding, she said, find the empty rules. Eliminate, she said, the empty rules. So in order to do that, I have to find all the non-terminals that eventually reduce to the empty symbol. Okay? So who are they? C. C goes in one step. Who else? Well, who goes to C? B. A, okay. S. Hey, every symbol is reducible potentially to E. That's fine. I found them. So find all the symbols that can go to E. Okay. All right. Now, I'm still trying to eliminate the empty rules. What should I do? How do you do that? The guy who directly goes to C, get rid of it. You don't need that if you make these changes in the grammar. So C goes to E, get rid of it. Now go through the grammar, one rule at a time. And what? If on the right side of the rule, you got any guys in that set of the symbols that can reach E, do all possible combinations of them going to E or not going to E. Okay, so tell me, what should I write? S goes to APS. Do I need any rules to add? AB, because S could go to E. Okay. Let's see. Yeah. I was thinking, should I write on top of it? But you keep the original grammar in case as long as you want to compare it, you know, they will find the same grammar, the same language. Okay. S goes to AB. AB, say. The only guy allowed to go to E is S, which is fine. That rule I need. I cannot delete him. Because in this case, E was part of the language. How will you get E if E doesn't appear anywhere? Okay. What? E. Well, but in the next step you will eliminate this empty rule. Okay? That's fine. That's fine. E. What? B. Okay, that's it. Now, B goes to E. What did it? But if you see it anywhere, you better make it go, okay. Now, A goes to E. Well, delete it. But if you see A anywhere, you know. You already done that, so you can safely delete them if you don't want to bother. You're not blind, you know, so you're human. So get rid of them. I don't need to say 1 goes to E. I did what she said, eliminate empty rows. Okay, next step, what should I do? Chain rules. Okay, I have to find the chain which is easy as a human here, right? I'll say, well, S goes to, no. Okay, A goes to B, B goes to C. That's the chain. A goes to B, B goes to C. All right, what do? I start at the end of the chain. B goes to C. Instead of B goes to C, delete that rule and replace him by whatever C goes to, which is A, B, A. Okay, next what? What should I do? To B. And instead of B, you replace it with what? This whole, yeah, okay. That's it. Do I have any more chain rules? No, I got 3 rules. Okay, what's the next step? Why don't you do that thing there with the alphabet symbols? Because we have mixtures of terminals and non-terminals. So create 2 new symbols. What's the alphabet here? A and B. Let's create 2 new symbols, X and Y. And their whole purpose is to go to the alphabet symbols. Okay? Okay? Then? Huh? Well, go ahead and replace. Everybody will become a bunch of terminals, a bunch of non-terminals. Okay? So this guy will become X, Y, S. Becomes YY. Now look what will happen here. What? Which are unreachable first? Yeah. Okay, something is unreachable if from S, there's no way to derive using a sequence of substitution. Okay. How do I find the unreachable? Find the reachable, the ones you can reach first. Okay, what can I reach from S? Okay, I can reach A, I can reach B, I can reach C, I can reach D. Right. Okay. That's the symbols reachable in one step. Now, whom can I reach from those? So eventually, from S I go to a combination of those. Then if I have a rule whose head is one of those, I can use him and get some more, reach some more symbols. So what is W2, the superset of it? Well, you look at all of the rules whose left side is in here. And any non-terminal you have on the right side, it is also reachable. So look at the rules with left side A. Well, so B should be reachable, but they already have it. B. C should be reachable, X should be reachable. Oh, X is a new one. Okay. S are reachable, X is reachable. What did I do? C? I did B. C. B, yeah, already have it, it's reachable. D. D, E is reachable. Okay. Step 3, Anybody that can be reached from any of those is good. Okay? I already did the rules, whose left side is this, so I got to use the new symbols that are reachable and see what's reachable from them. So X, E, D, already got it. Those are all the symbols that are reachable. What's left will be unreachable. Do I have anything left? No. Oh, everything is reachable then. Okay, so there's nothing to eliminate in terms of reachable. Okay, eliminate the useless symbol. The symbol is useless if, when you start with it, there is no way to find the sequence of substitutions to get down to sigma star, to all terminals, right? Then it's useless. It cannot be substituted by terminals. How do you find the useless? Find the useful. Okay. How do you find the useful? Useful in one step would be the guys that directly go to sigma star. Right? So find all of those. Then useful in two steps will be the guys that go to a combination of guys who are in W1, who are useful in one step. These guys will be useful in two steps. Right? They must go to a combination only of elements that are useful in one step. Useful in two steps, that's the algorithm. Okay, so what are the useful guys here? Is this useful? No, I think he better be at the end, otherwise the grammar would be what? Let's say I did the useful algorithm, find the useful symbols. An S never became useful